The broadcast is now starting. All attendees are in listen-only mode.
Hi everyone, my name is John Barnes. Welcome to the private VLAN Advanced Switching Tips and Tricks webinar. I'd like to start out by telling you a little about myself. I have over 20 years of IT experience. However, I'm only 25 years old. We'll get into that later. So I've been doing this quite a while. I'm a contract instructor for Global Knowledge. So I own a consulting company. So we do network integrations for the Marine Corps, a little part of the Marine Corps. So we currently build deployable data centers, and those data centers leave with the jets and helicopters and things when the Marines deploy overseas, excuse me, or deploy anywhere. So my specialization, currently is in data center. I also teach VMware, Cisco voice, routing, switching, and security technologies, and obviously work in all those fields as well. So recently we designed an integrated and end-to-end deployable data center. So we did that for several units. There's several tactical networks in the Marine Corps. So we did a proof of concept, designed and integrated that end-to-end. And so that's my experience. So I do teach for Global Knowledge, obviously, and then I also do some integration and consulting. So what we're going to talk about today is basically just a VLAN review, and then we're going to get into the function of private VLANs. So we'll talk about, just as a review, some basics about VLANs. So, this was really the first virtualization piece that we had in networks or in the data center, really anywhere like that. So a lot of things are virtualized now, but this was kind of the bleeding edge, as we called it at that time. So what a VLAN would do for us, it gave us the opportunity to separate the physical from the logical network structure. So, if you can think of how virtualization works, this was the first step again. So we had our physical networks where the cables actually plug into the ports, or even back to vampire taps if you go back that far. So that existed, and then, as technology advanced, VLANs were introduced. And so with a VLAN, you assign a user to a VLAN or a port to a VLAN, but it really no longer depends on the physical location of the user in the network with a virtual LAN. So if you think of the concept of a physical local area network, we have a cable that's 500 meters long. We have devices hanging off that. That's one local area network, and that would be one broadcast domain. Well, as technology advanced, we could still have, a 500-meter cable, but we could run different, segments on the one physical segment. So again, that's the first step of virtualization. What that gave us at the time was employees belonging to the same interest group, for example, can be joined in one, or could be joined in one virtual, LAN group, and regardless of their physical location. So under organizational aspects, all members of a department, can work to form a network group, even if they're distributed on different floors of a building or even across several buildings. So if colleagues were working on the same project, they can be united in a common VLAN, even if they belong to different departments or in different buildings or different locations. And that actually did reduce cost. If you think about having different segments and moving people around or moving equipment, it's much easier just to make a change on the virtual LAN and obviously change the physical LAN. So your network operations are reduced, and networks can easily be adapted to new requirements, right, by using VLANs. Again, if you compare, changing cables and plugs into a ports to a small configuration, obviously, much easier. Network changes are much easier with VLANs, so one time we were forced to spend a lot of time moving users and moving workstations, moving servers at that time. There are several tools, of course, to facilitate network management, but VLANs is pretty much the base of that today. So it does reduce operating cost, with the ease of network change. Basically, less man hours, reduce our cost there. VLANs are also, we say they enhance network security. Some people say it's a baseline. It's not the way to secure a network, but it is a dividing point or a starting point for security. So communication between two individual workstations, if that needs to be prohibited at a low level, then you can use a VLAN to accomplish that. So an example today, if you had a switch and you plugged two workstations into that switch, by default they can share information with each other because they're part of the same VLAN or the same broadcast domain. So if you need to prohibit that or isolate those, as we call it, then you would obviously put ports in different VLANs, and so they're isolated from one another. And we'll call that isolated at layer 2. And when we talk about layer 2, we're talking about layer 2 of the OSI model. Right? So you're isolating it at layer 2. So without VLANs, all workstations would belong to a single broadcast domain. So by adding VLANs, we can put different workstations in different broadcast domains. When I say the term broadcast domain through this webinar, it's used interchangeably with VLAN. So a VLAN truly is a broadcast domain. So let's discuss that for just a second. We're specifically referring to a layer 2 broadcast. So you can kind of correlate again, a VLAN is a broadcast domain which operates functionally at layer 2. So if you have a workstation, that workstation, when it sends out data, if we just talk about how it's going to work at layer 2, if we're sending from the workstation to a web server, some startup company called Google, something like that, I think they're going to make it. But so if we're sending data from your environment to Google, that workstation, one decision it's going to make is my destination, right, destination where I'm going, the destination IP address, is that off my network or on my network? So if it's off my network, meaning on a different subnet, then obviously we're going to send to the default gateway, right? And that's all pre-configured in the IP stack. Now we send to the default gateway at layer 2, not layer 3. If we think about that process, when you send a packet from your workstation to a Google web server, your destination address never changes. So all through the internet, your destination address is still the same. At layer 2, your destination MAC address changes at every routed hop, as we call it. So back to my original statement, when we're going to send data from the workstation to Google's website, if it's off net, then we're going to send to the default gateway. What that means is when we package up that data and we add the layer 2 frame, the destination address will be the MAC address of the default gateway. All right, so that's what we're referring to there. So we would send to the default gateway. The gateway would accept that information because it would check the layer 2 address. Well, that destination address matches mine. It would process the packet. Now, if we go back to the same workstation and we're going to send data on the same network, so one workstation sending data to another workstation, then we would still have the same question. Am I sending my data off net or on net? Obviously, it's going to be on net. We're in the same VLAN, same subnet. In that case, we would do something called a local ARP, address resolution protocol, if necessary. So what that means is you would actually send out a frame saying, I want to talk to IP address 10.1.1.5, and I would like the MAC address of 10.1.1.5. So that's essentially what happens when you do an ARP, address resolution protocol. Now, that ARP frame must be sent to all workstations, of course, right? But only the workstation with 10.1.1.5 would respond. Now, when we define all workstations, what we're talking about is all the workstations in the same broadcast domain, all the workstations in the same VLAN, right? So if you think of a VLAN being called a broadcast domain, if you have a workstation that sends out a broadcast frame, then how far will that go, right? How many devices does it actually cross? Well, it will go to all the devices within the broadcast domain. And how you limit a broadcast domain is by configuring VLANs on a port of a switch. So if you take that thought process, by establishing VLANs, your broadcast traffic can be reduced considerably, right, on a network, or even on an individual subnet or even across a backbone. If you had one flat network, you had 10,000 workstations, flat network meaning one VLAN, that would be overloaded with ARP requests and broadcast. when I talk about a broadcast frame in this section, the destination address is, all Fs or the bits are set to 1. So that means everyone will process that frame that receives it. So you have to be in the same VLAN to receive that. So a couple of things about the VLAN. Every packet sent from any workstation, right? It can only be associated with one VLAN, right? So as you send out data, it will only go into one VLAN, we should say. So a workstation receives, multicast packets, broadcast packets within its associated VLAN. So if you consider yourself a workstation, congratulations, then you'll only receive traffic from any device within your VLAN. So if you're thinking, hey John, what if I'm going to talk to you from another network or another VLAN? Well, that means you would have to go through a router, and that router would have one interface in your VLAN, one interface in my VLAN. So therefore, the statement is true. You'll only receive data from a device in your VLAN. So you would never receive data from a device outside your VLAN at layer 2. So a workstation can receive unicast packets, packets that are addressed to an individual receiver transmitted within the VLAN. So your multicast, your broadcast, your unicast packets all come from a device within the same VLAN. So your VLANs will divide traffic, similar to a router, but a VLAN is a layer 2 concept. A router operates at layer 3. So it's very important to limit, broadcast domains today. We don't want broadcast storms, and broadcast is just excess traffic. We have to support broadcast, however. It's part of the Ethernet standard that we use, but we don't want an abundance of broadcast. That's really just a waste of bandwidth. So there are several ways to look at a VLAN. On the slide, I have VLAN 10 equals broadcast domain 10. So again, that's just reiterating that a VLAN is a broadcast domain. So in some of the switches, you'll actually see the data structures listed as a broadcast domain, and most are VLANs today, but some of the older boxes actually say broadcast domain. Now, so a VLAN or a broadcast domain is layer 2. I've said that a few times. One more thing about layer 2. When we discuss layer 2, we're dealing with MAC addresses, 48-bit MAC addresses. So you've probably heard the term that a switch is a layer 2 device. Well, the reason it's a layer 2 device is because it forwards frames based on a layer 2 destination. It does not make a forwarding decision based on a layer 3 IP address or a layer 4 port or anything like that. It just makes a forwarding decision based on a layer 2 destination address. Therefore, a switch is called a layer 2 device. A router is a layer 3 device. It makes a forwarding decision based on a layer 3 address. Right. So layer 2 and layer 3. Now, as we move down to the next bullet on the slide, the one subnet per VLAN. So the way we deploy our networks today, we will create a VLAN, we'll put ports in a VLAN, and then we'll attach workstations or servers or printers, depending on what area of the world you work in. Now, one rule of thumb that we always follow is you have one subnet per VLAN, right? So if I have VLAN 10, then I would have one subnet that that's associated with that VLAN. It doesn't matter, there's no restrictions on how many devices are in that VLAN, how large the subnet might be, right? The restriction is simply one subnet per VLAN. Now, if you think of devices, talking to the default gateway, to get out of your network, you have to talk to the default gateway. So there's one default gateway also per VLAN. So we have one VLAN, and then we have one subnet per VLAN. An example here, I have two separate subnets, 10.10.10.0 with a 24-bit mask, and then 10.10.20.0 with a 24-bit mask. So you can clearly see the third octet, has different values. That's two different subnets for each VLAN. Now, the next thing I'm going to talk about is a private VLAN. So I said previously that inside, when we create a VLAN, that's one broadcast domain. So we have all these devices that can talk within that domain. If you take that step, just a little farther, what if we created VLANs inside VLANs, or a broadcast domain within a broadcast domain? So that's the concept when we have a private VLAN. Now, what we'll know that as, what we'll actually recognize that would be is a primary VLAN. That's your normal VLAN that we configure on a switch. And then the secondary VLANs, that would be, excuse me, the secondary VLANs, that would actually be the VLAN inside the VLAN concept that I spoke of. So we always have a primary and a secondary VLAN when we deploy private VLANs. Excuse me. So anytime you deploy a private VLAN, you have two parts. You have a primary VLAN, you have a secondary VLAN, right? And that's going to exist, anytime you create a private VLAN. So before we go into the mechanics of, how we do a private VLAN, let's talk about why you would do a private VLAN. There's many use cases for this. It's common to see private VLANs used on a DMZ within a firewall. So, if you're providing, if you're a service provider and you're providing server access, you want to isolate those servers just like we do on a DMZ. So let's use a DMZ example. If I have 2 web servers on the first 2 ports of a switch and then a database server on the next 2 ports of the switch, I do not want those 2 servers to communicate with each other. So I have 4 servers. Let's divide those, 2 on the left, 2 on the right. The 2 on the left are web servers. The 2 on the right, again, are database servers. So the web servers obviously are going to receive traffic from, the outside. People will access the web server to get our web pages, buy the products, whatever the case would be. On the back end, those web servers may reference the database for information. So if you want to get a quote for your new Porsche or your new Ferrari, maybe that is referenced from that database. Now, so we want the web servers to be able to reference the database servers. However, we do not want the people accessing the web server to be able to access the database servers, right? So that's our private information. Now, one way to do that would be you'd say, hey, John. I'm like, yep. You'd say, well, why don't I just put the first 2 servers in one VLAN, the web servers on the left, put those in one VLAN. And then the database servers on the right, put those in another VLAN. And there's nothing wrong with that. The challenge would be, remember, we have 1 subnet per VLAN, right? So if you have 2 servers that are called web and 2 servers that are called database, that means you're going to have 2 devices in one subnet, 2 devices in another subnet. So, that would make that a /30. If you grow that concept, having 2 and 3 and 4 servers in each subnet, pretty soon your routing tables will get really large with a lot of networks. And so very few network administrators would allow that based on policy and experience. So the network team would say you cannot have multiple small subnets, but I'll give you 1 subnet. So now we're back to the drawing board. So I have 1 subnet and I have 4 servers, but I need to divide those. I want isolation between those servers, the left web servers and the right database servers. So what I can do is create 1 primary VLAN. We'll call that VLAN 454. So I have a primary VLAN, and I will put, all 4 servers in the primary VLAN to start with. Then I will create secondary VLANs. Now I'm going to create, my primary VLAN was 454. My secondary VLAN, my first one for the web servers will be 396. So I create that for the web servers. The database servers will be VLAN 427. So I actually have 3 VLANs at this point. So now I will apply VLAN 396 to the web servers, VLAN 427 to the database servers. However, I will make that a secondary VLAN. All right, I have a secondary VLAN. So now I have the primary VLAN, and then I have 2 secondary VLANs. Now on the next slide, we'll talk about how these actually operate. So your primary VLAN always has what we call a promiscuous port. And the idea here is, certain VLANs can talk to certain ports. Remember the idea, we're trying to isolate the web servers. We want those 2 to talk to each other. We want the database servers to talk to each other. But someone coming into the web server cannot also access the database servers. So we're providing isolation. What a promiscuous port would do for us is that would allow the web servers and the database servers to talk to their default gateway. because those servers still reside on the same subnet, so they would all have the same gateway. But again, we're trying to isolate those servers. 2 web servers on the left, 2 web servers on the right. Now, the next bullet, it's configured as an interface, configured on an interface as a private VLAN promiscuous port. That's something you actually have to configure. That's nothing that's auto-configured. So far, we've created 3 VLANs, 1 primary, 2 secondary. We're also going to identify a promiscuous port so that these devices can all talk to their default gateway. But we still want to provide isolation between these devices, which comes to our secondary VLANs. So when we talk about secondary VLANs, right, you have 2 types of secondary VLANs. So there's a community secondary VLAN, and then on the next slide, we'll see that there's actually a isolated secondary VLAN. So on the web servers or on the database servers, remember we had VLAN 396 on the left for the web servers. We had VLAN 427 on the right for the database servers. Let's go to the web server VLAN 396. On VLAN 396, I can make that a community VLAN. It's always going to be a secondary, but I can make it a secondary community VLAN. What that means is the 2 web servers can talk to each other. They can share information at layer 2. So if one web server sends a broadcast frame, the other web server would receive it, and vice versa. So they have communication at layer 2. This is like a normal VLAN function. However, they cannot talk to any other ports on that switch except for the promiscuous port. The promiscuous port, as the name implies, talks to everyone. All right, so that port can communicate with anyone. So we've created a secondary VLAN, and we've labeled it as a community VLAN. So the 2 ports in the VLAN can talk to each other, the 2 web servers can share information, and they can talk to the promiscuous port. The reason they need to talk to the promiscuous port is because that's where the default gateway would reside. If we go back to the start of this session, we said we have a device. It's going to send a packet. So it's first going to determine if it's on net or off net. If it's off net, we must send to the default gateway. All right, so same concept here. You access a web server, you get information. When that web server replies, it has to make a decision. Is this reply going to be on net or off net? If it's off net, we go to the default gateway through the promiscuous port. Right? So again, that's a secondary VLAN, right, that's configured as a community VLAN. So the 2 web servers can talk to one another. Now we also could make VLAN 427 on the right for the database servers. We could make that another community VLAN. So we could have 2 secondary VLANs, right, and both of these would be community VLANs. What that would do for us is the 2 database servers on the right could share information at layer 2. The 2 database servers on the left, the web server, could share information at layer 2. However, the web servers on the left cannot talk to the web servers on the right. All right, the database servers on the right. The database servers on the right, right, cannot, share information or talk to the web servers on the left. All right, so that's how we're getting isolation and still utilizing the same subnet. All right, so the IP address structure, starting from the left, could be 10.1.1.5, the next one 10.1.1.6, the next one 10.1.1.7, the next one 10.1.1.8. They're all in the same subnet, but they're isolated at layer 2, right, because of the secondary community VLAN that we configured. Now, with that concept, some people ask the question, well, what if you looked at that at a routing perspective? Couldn't I send traffic from 10.1.1.5 to 10.1.1.7 through the router? And the answer is you cannot, right? Because there's a couple of reasons. Let's start with the server itself. Web server number 1 over here, it's 10.1.1.5, trying to talk to database server 10.1.1.7 on the right. If you think about the destination IP address and the source IP address from that web server, the destination IP address would be 10.1.1.7. The source IP address would be 10.1.1.5. That server would think that it's talking on its network, so it would not send to the default gateway. It would try to do a local ARP. The ARP would not succeed because we have those ports isolated at layer 2. So a broadcast frame from the left web servers cannot ever reach the right database servers. So that's reason number 1, it wouldn't work through the router. the server would never try to send it to the router because it's on net. It's part of the same network. Now, the other reason would be if you ever found a way to get information to the router, right, the router is not going to receive a packet on an interface and then route it back out the same interface. And that's just not the way routing works. So it does work for isolation, right? So that's a secondary VLAN community port. We also have a secondary VLAN isolated port. And we generally refer to this as a secondary VLAN that's isolated or a secondary VLAN that's community. You can use these interchangeably, so I could have 3 VLANs that are community, 1 VLAN that's isolated. So what we'll do is we'll use the database servers as an example for our isolated secondary VLAN, and we'll use the web servers as an existing secondary community VLAN. So the web servers on the left, they're in the community VLAN, and there's 2 of them. So the web server 1 can talk to web server number 2. However, those web servers, again, cannot talk to the database servers. They're in different, secondary VLANs. Now, if we move to the database servers on the right, if we make that a secondary VLAN and make it an isolated secondary VLAN, that means those devices cannot talk to anyone. So meaning database server number 3 cannot talk to database server number 4. Database server number 4 cannot talk to database server number 3. So they cannot share information at all. Even though they're in the same secondary VLAN, since it's isolated, they cannot share information with one another. However, an isolated VLAN does have the capability to talk to the promiscuous port. Right? So again, the promiscuous port, as the name implies, talks to everyone, community or isolated, doesn't really matter. And if you think about that process, it would be necessary for an secondary isolated VLAN to talk to the promiscuous port. Again, the promiscuous port is where your default gateway resides. Right? So if you're going to access the database server from a different subnet, then obviously the database server would have to access the default gateway to return traffic. And so that would be no different than the example I've given before. You're a database server, congratulations. And if you receive traffic and you're going to reply, you'll do the same thing you always do, right? You're very process driven. You'll say, is this packet on net or off net? Well, if it's off net, you have to send the default gateway, right, which would be accessed through the promiscuous port. So 2 types of secondary VLANs, again, would be isolated VLAN, where the ports cannot share information at all except with the promiscuous port. And then we also have the community VLAN. Right? And again, the community VLAN, they can talk to members within the same community, within that same VLAN, and the promiscuous port. However, they cannot talk to another secondary VLAN of any type. So what we achieve with this, again, is we provide isolation at layer 2 with the same subnet, so the same layer 3 structure with secondary VLANs. If we look at some of the private VLAN operation, and the, private VLAN operation with the primary VLAN, your primary VLAN is actually used to forward frames upstream to the router, right? So through that promiscuous port, the primary VLAN is used to access the router. So again, when we look at the configuration of this, you would configure a VLAN, and then you would make that the private VLAN primary. The other VLANs you would make private VLAN secondary, then determine if those secondary VLANs would be considered isolated or community. Also here, used to forward frames downstream from a promiscuous ports to community and isolated ports. And what we're referring to here is traffic coming through the default gateway going to access the web servers or even database servers. So in this case, the primary VLAN would be the transport to send traffic from the default gateway to the web servers or from the default gateway to the database servers. The isolated secondary VLAN, this is a real simple concept. It's a simple data structure. It's used to forward frames from an isolated port to a promiscuous port, and that's really the only data path that you have when you configure a private VLAN with an isolated secondary VLAN. Right? Because remember, in an isolated VLAN, no port talks to any other port. It's truly isolated. So the only port that you get to talk to is the promiscuous port, right? And that's how you access your default gateway. And so it's a real simple data process in that case. With the community VLAN or the secondary VLAN, this is used to forward frames between ports in the same community VLAN. So that's step number one. So remember, when you have a secondary community VLAN, one device in the secondary VLAN can talk to other devices in the secondary VLAN if it's tagged as a community VLAN. Now, it's also used to forward frames from the community ports to a promiscuous port, and that would be how the devices that are configured in the secondary community VLAN access their default gateway. So that's the operation of a secondary VLAN. Again, the isolated is very simple. We go from an isolated port to a promiscuous port. A community VLAN, we go from one port to the other within the same community, or we go from one port to the promiscuous port, which is the default gateway. So that's a little bit of an easier way to look at that. And one thing that before we talk about the configuration, one thing you can tie into this, you can do many different things with VLANs. But you can create, a MAC address based VLAN. So, if the MAC address of a workstation is assigned to a VLAN, each switch would maintain that table. So you could build a VLAN based on, MAC address memberships. You could build VLANs based on, your protocols, right? Different protocol-based VLANs. So the configuration doesn't change, but how you design it might change a bit, based on what your requirements are. And then also, when you're going to send information from one VLAN to the other, that's where we get into routing. And the term that you may hear is layer 3 switching. So, if we have a switch that does layer 2 functionality and layer 3, we typically refer to that as a layer 3 switch. I bring that up because a lot of your documentation today, it will list a layer 3 switch. But, not to be confused, that's actually routing. So if we think about the process of routing, you're moving data from one segment to the other. You're switching it through the router. When you switch that data through the router, then you're actually decrementing the TTL field by 1. You're removing the source and destination MAC address Ethernet frame, basically, and adding a new one. So that happens anytime you go through a router. When you go through a layer 3 switch, the exact same thing happens. So, you're still going to be doing the routing function, probably on a switch virtual interface. The TTL will be decremented by 1. The Ethernet frame will be removed on the ingress or inbound, and then will be, a new Ethernet frame will be added on the egress or outbound. Right? So, one of the benefits of VLANs, in a layer 3 switch, you don't have to have a physical router, right? You could actually do all of this inside the same switch. So if you have 2 workstations, 2 servers that are actually on different VLANs, and they want to communicate with one another, you have to go through a router. And so, some people refer to this as inter-VLAN routing. We have a layer 3 switch. We can route between the VLANs on the same switch. So whether it's, community VLAN, primary VLAN, it really doesn't matter. So if we talk about the configuration here, in this example, we have VLAN 100, and we said this is private, VLAN, and primary. So when you create a VLAN on a Cisco switch, you go to configuration mode, you'll type in VLAN 100. Your prompt will change, config-VLAN. And at that point, you can type in this command, hey, let's make it a private VLAN, right, and let's make it the primary. So what these steps would do, it would create, a VLAN 100. It would be considered a primary VLAN, but at this point, it has no secondary VLANs associated with it. So in your switch, you would have VLAN 100. It's a primary VLAN, does something, but we don't know yet. Right? So we've created a primary VLAN, primary private VLAN. The next thing, we have VLAN 15. So we have private VLAN, and we made that a community VLAN. So with that's a secondary VLAN. You have community or isolated as the option there. So this would create a community secondary VLAN. It would be VLAN number 15, which will eventually associate with a primary VLAN. One thing to understand, as you go through and configure these VLANs, when you type in private VLAN primary, that and then private VLAN community, there is no association with those at this point. So there are it's two existing VLANs, all right, in your switch, but there's no tie together. There's no linking these together as primary and secondary. So we're just creating VLANs to start with. The next example is VLAN 25. We would type, VLAN 25. The prompt would change. We would make it a private VLAN community. So essentially, we've created VLAN 25, right, and we've made it another community secondary VLAN. So far we have VLAN 15, we have VLAN 25. Those are both community VLANs, secondary community VLANs. Now the bottom example, we show a private VLAN isolated, so it's VLAN 35. And so we said private VLAN, but now we're going to make that isolated. So we have two community VLANs, 15 and 25. We have one isolated VLAN, which is 35, and we also have a primary VLAN of 100. Again, there's no association of these, linking these guys together yet at this point. They're just VLANs that exist in the database. When you configure private VLANs, one thing is, your private VLAN configuration needs to be end-to-end, meaning if you cross 4 switches from point A to point B, all 4 of those switches need to be primary VLAN aware, and they need to have, which means you would have the private VLANs configured in the switches. So again, that's private VLAN aware, I think I may have said primary, private VLAN aware, right, on all of your switches. So, if you configure private VLANs on one, and you're going to send that data to another switch, you need to create the private VLANs on the upstream switch also. If you don't do that, then the receiving switch has no idea that that's actually a private VLAN. So let's tie these together. So we have private VLAN association, and then 15, 25, and 35. So what this would do, we're under VLAN 100. We're associating the VLANs, so 15, 25, and 35. So what that would do, it associates secondary VLAN 15. Remember, that was one of the community VLANs. It would also associate secondary VLAN 25. That was our community VLAN also. That was our second community VLAN. And then we had secondary VLAN 35, which was the isolated. And so that ties those together with primary VLAN 100. Now at this point, it's all looked at as a combined data structure. So if you actually look near your switch now, you would see a mapping with the primary and private VLAN associations. Excuse me. Now, sometimes I'm asked the question, if you already have your private VLAN set up, can I go in later and add a secondary community VLAN? The answer is yes, you can. Right. So you could continue to add secondary VLANs in your private VLAN structure. Now, if you have a primary VLAN, multiple community VLANs, the rule of thumb is there is only one isolated VLAN associated per primary VLAN. So you can have a primary VLAN, you can have multiple secondary VLANs that are community VLANs. However, you can only have one secondary VLAN that's isolated. Which kind of makes sense. There's really no need to do multiple isolated VLANs. Remember what you're trying to accomplish with the isolated VLAN. Every port is isolated from one another, right? So, every port's isolated. The only device, only data path you have is from an isolated port to the default gateway through the promiscuous port. Therefore, there's really no need to have multiple isolated VLANs. Now, if you look at the community VLAN structure, that's where we have multiple devices talking within the same community. So therefore, you would want multiple community VLANs. So web servers, app servers, database servers. Maybe those are all in the same secondary community VLAN because we want the web servers to talk to each other, the app servers to talk to each other, right? The database servers to talk to each other. However, we may not want, web to talk to the database or vice versa. So that's why you would have many community secondary VLANs. And this is the association of those. So that was an overview on the private VLANs. A couple of things to remember with the private VLANs. When you set up routing for private VLANs, it's just like you would have your routing normally. So when you want to lay out that structure of setting these up, you have your routed network, That could be through switch virtual interfaces that we talked about. It could be through SVIs, switch virtual interfaces, or routers or switch virtual interfaces. It doesn't really matter. Your switching is in place. You have one subnet per VLAN. So essentially what you're doing is you're going into a VLAN and you're breaking that VLAN into smaller broadcast domains, but you're not affecting the routing. You're not affecting any layer 3 addressing or anything like that. Right? So what that gives you is the capability to provide isolation within a VLAN. So again, commonly used on the DMZs and firewalls when there's subnetting challenges, and just for isolation instead of using multiple subnets over and over again. So your routing does not change when it comes to that. Your physical infrastructure does not change, of course. Your physical cabling remains the same, so you can add or delete devices just like you always have, but there's no change to the physical infrastructure to support a private VLAN. And also private VLANs do support tagged packets. So when we refer to tagged packets, we're talking about 802.1q. So if you're sending from one switch to the other with multiple VLANs, that traffic will be tagged between those VLANs with 802.1q. So I have a switch on the left and a switch on the right. The switch on the left has VLAN 10 and VLAN 20. The switch on the right, has 10 and 20. I have one link between those switches though. So, I have my broadcast domains 10 and 20 separate on the switch on the left, and they're also separate on the right. So how do I keep those separate when I send traffic across that link, that one single link? And the answer is the tagging that I'm referring to, 802.1q. Right? So what 802.1q will do for us, it will add a header, right? Or we call it a VLAN tag, right? It's a 4-byte field that it adds to the frame. So what that will do is it will tag traffic, meaning if you're in VLAN 10, when you leave the switch on the egress, the outbound, it will tag that traffic as VLAN 10. If your traffic that's sourced from VLAN 20, it will tag that as VLAN 20. So as we're sending traffic from the switch on the left to the switch on the right, it will actually tag that traffic. So now from the left switch going to the right, we've tagged those frames as VLAN 10 or VLAN 20. Switch on the right receives those. The first thing it will do, will read the tag. It will say, we'll look at the tag. Well, this packet is part of VLAN 10, so I'm only going to send it to ports in VLAN 10. So if it's a broadcast frame, then it would only go to the ports that are configured for VLAN 10. If it's tagged for VLAN 20, it would only go to the ports that are tagged as a VLAN 20. All right? So that concept that I just had a little review on, that concept of tagging, that still is in effect when we use private VLANs. So 802.1q is still used just like it is with normal VLANs. We do not add an additional 802.1q header. There is a concept of what's called Q-in-Q tunneling that is not used with private VLANs whatsoever, so common misconception. So we tag that information with private VLANs, just like we do with normal VLANs. And as that's tagged, when it goes to a layer 3 device, of course, the frame is removed and added. So there's no change in functionality from a routed standpoint. The change in functionality comes at layer 2, right, in the broadcast domains. So again, as a recap, private VLANs, right? This is simply adding a broadcast domain inside a broadcast domain, right, to provide more isolation and another basis for security. All right, I hope that's you got what you needed out of this. And on the slide up here, we have some recommended courses. There is a switch course, Implementing Cisco IP Switch Networks, version 1.0. This covers VLANs. It covers private VLANs. It covers trunking. We also cover how to route between those VLANs. So we'll do route with static routing between VLANs, route with OSPF and EIGRP between VLANs, and we'll also implement private VLANs and let you work with those in there. Many, many other things in the switching course, but we do cover everything that I talked about here. If you're interested in an on-site, we can tailor our courses to meet your needs, meaning, if you want specific sections or specific modules or specific protocols delivered on-site, then we can, customize a course and deliver that in a private setting, at your workspace or even virtually. Right? So feel free to request that. That concludes the session on private VLANs. Again, my name is John Barnes, and I can be reached at johnrbarnes@earthlink.net. Please feel free to email me for any questions. Thank you very much.